everyone. Thank you very much for joining us today. We are the editorial board of the book Methods for Faecal Sludge Analysis. And we chose this session to bring a little bit more awareness about this publication because it was published quite recently this year. We have this session planned in two parts. The first one is just bringing awareness on the content of the book. And then we're going to say, some of the lead authors are going to say about some of the chapters, and we're going to introduce you to the concept of this project. It would take about 45 minutes. We have prepared pre-recorded videos for that. And then the second half would be, again, about 45 minutes where we would have a live discussion with you. And then, yeah, you can pose your questions, and we would like to hear from you. Also, I wanted to say that just before we start with the live discussion, we would have two questions for you. So please pay attention to the content of the presentations, and you may also get a chance to win one of the copies of the book, which is here with me. Okay, we have about 24 people. So Eva and Jan are in the background. They're helping us with the technical arrangements. Eva, would you be able to play the video?
Sorry, slight technical errors, just figuring it out.
Tina, even though we're virtual, it's so great to see the pictures of so many people I recognize in the participants.
I know, that's correct. While we're waiting for Eva, maybe.
Oh, here she is.
Okay, that's perfect. Yeah, okay, so maybe we can introduce each other
I'm Carl Henson, Program Officer in the WASH team at Bill & Melinda Gates Foundation. And the project resulted in the methods of fecal sludge analysis belonged in my portfolio. And for that reason, Tina asked me to say a few words. So towards the end of 2012, there was a discussion with Chris Buckley how his then pollution research group, now the WASH R&D Center, could help support the activities of our developing reinvented toilet portfolio, where we were bringing in a number of chemical, mechanical engineers and scientists, numerous disciplines, but they didn't have experience with fecal sludge. And we really needed the grantees to be consistent in the methods and approaches they took. Now, the PIG were asked to help familiarize these new folks with their methods of testing they would need. But by 2016, as the portfolio grew, it was pretty obvious that we would be wasting a large amount of PIG's time if we kept sending everyone to Chris and Tina via email. So I was sitting in a bar one night, and as we all often did with Chris, pretty sure it was the Hilton Hotel Bar in Durban, I suggested that he pulled all of his SOP files together in a PDF and one that could be downloaded. Chris, of course, was already ahead of me and suggested that we create a small book that helped along with some background knowledge. And the two of us agreed it would be a great project for Tina to lead. So Tina obviously had other ideas beyond producing this small book of SOPs and information just from the PIG lab. She obviously reached out to a number of her colleagues, those on the panel today and others, aiming for something that was compiled from a diverse set of experts in the field. And there was always an expectation that we would need this book to be freely available to those folks who didn't have the luxury of resources. But they're working hard in the field to advance the knowledge of fecal sludge management, and they are the ones that really are training those new generations of sanitation scientists and engineers. At the beginning, I assumed this would just be a downloadable from the PIG website, but the International Water Association, the IWA, seeing how important it was to make this information available for all, have agreed to host the free downloadable version and produce hard copies for sale. So when you read through the manual or you're referred to its text, what you're actually experiencing is the passion of all of the contributors, especially the editors, and a generosity of time that I could never thank anyone enough for. I hope that you enjoy the panel discussion, and I really do hope that you enjoy the rest of FSM6.
The initial discussions of the need for standardized approach for methods and analysis in fecal sludge management started informally years ago during different events and convenings, such as the FSM conferences, for example. Through the years, it became
Do you all experience the same problem?
Yes.
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 Okay. Maybe, I'm not sure what is happening. Eva, please, in the background, try to help us with that. But maybe while we are waiting for this to be solved, we can introduce the board of editors.
Oh, now it's back, Tina.
Okay.
Oh, now it stopped again.
I'm not sure if
Sorry.
that's an internet problem.
Okay, Tina, since you're on the screen, maybe you could start by introducing yourself.
Let me start. My name is Konstantina Velkoshanova, or Tina. I am a senior researcher and lecturer in non-sewage sanitation at IHE Delft. Until recently, I was based at the previous pollution research group, now WASH R&D Center at UKZN in Durban, South Africa. Next one, maybe Linda.
Yeah, my name is Linda Strande. I lead a group called Management of Excreta, Wastewater and Sludge here at Sondeck, which is at EAVAG in Switzerland. And yeah, I was been working together with PRG and Tina for years now. And it was a great pleasure working on the book together.
Maybe we can move to Mariska.
Hi everyone, Mariska Ronteltap. I'm now with the Delftland Water Authority and I was at IHE for a long time. So many familiar faces here. Good to see you all.
Thank you, Mariska. Tamarat?
Hi, this is Tamrat Kutatep from Asian Institute of Technology, Thailand. I also work with Tina, Linda, Mariska, and Damir for quite some time on the sanitation in the ventures. Thank you.
Thank you. And Damir.
Hi, Berjanovic Damir. I'm professor of sanitary engineering at IHE Delft and the TU Delft in the Netherlands. I'm part of this board and I was enjoying working for a number of years on this book with all the members and all contributors. And I'm also leading a global sanitation graduate school. And students and staff there will have, I hope, lots of benefits of this book. And I'm really happy to be part of this launch. Actually, Tina, I think it is a kind of a launch of the book.
It is, yeah, a kind of a launch of the book. We hope that we'll have more events to promote it. And I also would like to acknowledge the contribution of Professor Chris Buckley, who also was on the editors listed in the book. So, Eva, do we have any progress with the video? I don't hear you very well, but maybe you can start it from where you can start with my part.
Events and convenings, such as the FSM conferences, for example. Through the years, it became evident that such standardized approach is crucial, as currently there are no standards for fecal sludge methods of analysis, and standards from different other fields are being adopted. The problem with this is that fecal sludge is highly heterogeneous, and it's very different than wastewater or soil or solid waste, for example. The other problem is that different organizations in different regions would modify and adapt standard methods from other fields differently in the way that best suits in their own capacity. With time, we managed to generate more data than we had 10 years ago. But there is a significant uncertainty of how comparable this data is between different regions and organizations. Carl Hensman provided some background on how the project started and the funding provided by the Bill and Melinda Gates Foundation. And the rest is just history. The editorial team met together on many occasions in different parts of the world. And finally, this publication came out as the first step towards standardization approach and the development of mutually agreed methods for fecal sludge analysis. The first intention of the editors was to focus on a joint publication of methods for laboratory-based fecal sludge analysis, but during the course of the content development, it was identified the necessity to expand the scope and share important practical developments in the field, divided into 8 chapters of the book. These include setting the scene, innovations, and current trends in the field, included in Chapter 1, considerations for the measurement and properties of characterization for fecal sludge, and guidelines for how to set up a fecal sludge laboratory in Chapter 2, different methods and techniques for fecal sludge sampling and handling, included in Chapter 3, practical tips of how to set up laboratory experimental design in a meaningful way to be able to support the design improvement of large-scale treatment technologies, which is included in Chapter 4. In Chapter 5 is discussed the importance and knowledge required to estimate the qualities and quantities of fecal sludge at scale, from community to citywide. In Chapter 6, I included modeling frames and approaches for fecal sludge processes taking place in containments, for example, and this is put into a citywide inclusive sanitation context. In Chapter 7 is highlighted the importance of fecal sludge simulants and their application for technology development testing, with some examples from different partners. And finally, in Chapter 8 are summarized laboratory procedures and methods for characterization of fecal sludge, including health and safety procedures, methods for sample preparation, handling, and analysis of fecal sludge. The lead authors of some of these chapters are going to say a few words about their content today. The importance of the global partnership of laboratories for fecal sludge analysis is highlighted throughout the book, and Damir Brjanovic is going to say a few words about this consortium. We, as editorial team, have learned a lot during the journey of collating this information and sincerely hope that brings value to the entire fecal sludge management sector. We plan that this is the first publication that may be followed by consecutive updates and additions when it's needed in the future. Thank you.
I'm sure that everyone here today agrees that integrated fecal sludge management plays a vital role in citywide inclusive sanitation. The goal of citywide inclusive sanitation is equitable, safe, and sustainable sanitation for everyone, achieved through implementation of a range of appropriate technologies tailored to the realities of rapidly growing cities. In comparison to sewer-based approaches in urban areas or pit latrines in rural areas, the concept of integrated fecal sludge management in urban and peri-urban areas of the entire service chain in the SDGs, incorporation of FSM in national regulations and development agency agendas, increased funding for research and implementation of infrastructure and service provision, development of curriculum, and increased evidence-based research and publications. It is important that we maintain the momentum of these positive developments and continue to focus on drivers of change, as there is still much work ahead. And there is a need for greater scientific knowledge to move solutions for fecal sludge management further forward. Since standard methods of sampling, laboratory approaches, analytical methods, and projections of modeling and fecal sludge do not yet exist, results are not comparable. The actual variability is not yet fully understood, and the transfer of knowledge and data between different regions and institutions can be challenging and often arbitrary. This book is designed to address those needs through methods of data collection, analysis, and interpretation. In order to pave the way toward increased scientific knowledge that will lead to an increased understanding of fecal sludge characteristics, its quantification, and the correlation to source populations. Through increased scientific knowledge, new solutions can be developed, research can lead to an understanding of treatment mechanisms in order to advance technologies and to reduce required footprints for treatment in urban areas. Reliable data can improve projections and modeling, which are needed for the reliable and appropriate design of treatment plants and transfer stations. Established methods of data collection and analysis can be used to establish guidelines and monitoring for the protection of public and environmental health, and advancements in scientific knowledge will elevate the perception of on-site sanitation as a sustainable component of citywide inclusive sanitation. If people at this meeting are aware of what fecal sludge is, but the usage of the word sludge varies quite a lot and can be confusing. There are many different types of sludge, and terminology is used differently by different practitioners. Types of wastewater sludges tend to be much more well-defined. In contrast, fecal sludge is conventionally referred to as fecal sludge throughout the service chain, from the time it accumulates in containments and passes through collection, transport, and delivery to treatment facilities. The terminology of fecal sludge also varies depending on geographic location, professional background, or preference. But different types of sludges actually have widely varying characteristics and are not comparable. And for this reason, we stress the importance of clearly describing where and how samples were taken during analysis and reporting of results to ensure transferability of knowledge. I will talk a little bit more about variability in the section of today's presentation on estimating quantities and qualities of fecal sludge. So in addition to a lack of standard methods, analysis is complicated by the wide range of technologies in each local context and the heterogeneity within systems, greatly complicating knowledge transfer. We need to start developing standard methods to improve communication among practitioners, designers, researchers, students, and teachers to build comparative fecal sludge databases of information and to increase confidence in results. This book addresses these challenges and provides a basis to start to establish standard methods. The methods in this book have been peer-reviewed and have wide acceptance in the sector, and they can now be further tested, evaluated, and discussed. Demir will discuss how the global partnership of laboratories for fecal sludge analysis will coordinate and move towards this process of establishing standard methods. In summary, this book provides an integrated approach to data collection and analysis of fecal sludge. How the chapters are all integrated and how to use them throughout your entire process are summarized in Chapter 1, and examples will be given today throughout this session.
Unlike wastewater, there are very few laboratories that specialize in fecal sludge analysis. In addition, due to the lack of standard methods for sampling and analyzing fecal sludge, standard methods from other fields, such as water, wastewater, and soil science, are usually applied. This is why the experts on fecal sludge analysis recently established the global partnership of laboratories for fecal sludge analysis to address these challenges and to work towards standardized methods for the characterization and quantification of fecal sludge from on-site sanitation technologies, including sampling techniques and health and safety procedures for fecal sludge handling. The partnership also delivers on-campus courses and training and aims to improve communication between sanitation practitioners, provide a comparative fecal sludge database, and improve confidence in the methods and obtained results. The partnership currently consists of 11 laboratories in Durban, New Delhi, Bangalore, Bangkok, Zurich, Delft, New York, Ouagadougou, Pilani, Kathmandu, and Bandung. Staff of these laboratories made a valuable contribution to the book Methods for Fecal Sludge Analysis and are expected to be the main vehicle in dissemination and testing of the methods described in the book. These and other labs will play an important role in further development and standardization of the methods for fecal sludge analysis presented in this book.
Now I would like to introduce you briefly to Chapter 2 of the book, Fecal Sludge Properties and Considerations for Characterization. Fecal sludge characterization is the process of measuring and evaluating fecal sludge properties. The characterization of fecal sludge as a material and understanding the nature of the physical, biological, and chemical properties or characteristics is necessary for the research, design, implementation, and operation of fecal sludge management solutions. This chapter presents background information necessary to understand before you use the methods described in Chapter 8. It defines types of fecal sludge based on total solids concentration necessary to implement the correct steps in the methods. It introduces factors that affect the variability of characteristics along the entire service chain, and then provides guidance of how to select appropriate methods for the characterization based on several criteria such as characterization objectives, relevant characteristics, desired level of accuracy, laboratory capacity, and available resources. The chapter then presents considerations for setting up a fecal sludge laboratory and includes 4 case study examples of how operational laboratories can look when implementing all the steps indicated in this chapter. Defining standardized methods for the characterization of fecal sludge is challenging due to the high variability of fecal sludge from the macro to micro level. In addition to the variability, different methods for sample preparation and analysis are appropriate depending on the type of fecal sludge. For example, samples with higher load, higher total solids content coming from dry on-site sanitation systems, such as pit latrines, will require different preparation than samples coming from wet systems, such as septic tanks, for example, that would have much lower total solids content. The solids content will also affect whether it is relevant to conduct volumetric types of analysis expressed in milligrams per liter, or gravimetric types of analysis expressed in grams per gram total solids of the sample. Qualitative observations of different moisture or total solids content of fecal sludge range from dilute and watery to slurries that are still pumpable to dewatered sludge that is shovable or spadable, but not pumpable. Although these differences do not have clear boundaries to be precisely defined, it is useful to define approximate ranges of type of fecal sludge based on total solids. The different ranges can help us to select the appropriate methods for analysis and also whether we want to undertake analysis volumetrically or gravimetrically. Here are provided the 4 types of fecal sludge that are defined in the book. When we speak about properties of fecal sludge and selecting of methods for characterization, we have provided different steps that need to be followed in order to undertake the characterization process correctly. Based on the defined purpose and the objectives of the fecal sludge characterization, the appropriate method for measurement of properties needs to be selected. After defining the purpose, objectives, and the desired properties to determine the characterization process, the next step is to select appropriate methods for analysis, taking into considerations the total solids content, the required level of accuracy, available resources, and laboratory capacity. The sampling plan prior to analysis is discussed in Chapter 3. We have provided 3 main groups of properties in this chapter, which are chemical and physical-chemical properties, physical and biological properties, focusing on mainly on pathogens in this book. And these reflect on the different methods provided in Chapter 8. And finally, we have provided a guideline of how to set up laboratories for fecal sludge analysis. Analytical methods alone are not adequate To provide reliable and repeatable analysis, we also need these analyses to be conducted by trained personnel and in facilities that are managed well and have relevant and strict standard operating protocols. Thank you.
Hi, this is Tamrat Kutate from Asian Institute of Technologies. I'd like to introduce to you the chapter in the group method for fecal sludge analysis. This chapter, we will talk about the fecal sludge sample collection and handling, how we can do that. But before we go into details, I'd like to share with you the techniques, the methods that we are doing in AT labs in our campus. So let's go.
Okay, let's see our solar septic tank, one of the innovation from the toilets that we are using and then we are experimenting right now. The sample that we collect from the system is that from the inlet and the outlet up there. But the only things that are here, it is in the experimental labs, we can handle, we can collect very simple. But in the field, it would be more challenging that how we can get into the tank and then get the right sample out of the tank. An example to get the sample of the fecal sludge from the treatment units like the wetland system, it is very easy if it is in the experimental lab like this. But in the field, we need to explore carefully that how can we get the dry sludge inside the tank, or how can we get the liquid parts out of the system that we can determine the performance of the system. This is our standard testing facility for the decentralized wastewater treatment system that we can arrange the samples according to our wish, either the scrap or the composite sample that we use the automatic sampling machines, and then can collect hourly about the influent and effluent of the system. This is the wetland unit treating fecal sludge, and then we need to think and plan carefully that we should not jump into the middle of the wetland just to collect the sample, but in advance, we have to plan the schemes of the sampling. How can we manage that and get the right information from the wetland system?
So let's come back to the chapter content. Then the contents of this chapter, I like to address the issue of the sampling techniques, the device, the locations of the samples. And then, of course, we need to think about that, the appropriate sampling screens and also the plans. And then these plans is to ensure that our sample can represent the characteristics of those units. And then we can talk about the health and safety issue for the people who work in this fecal sludge sample analysis as well. Then we need to prepare carefully that how we can collect and manage and handle the samples. Otherwise, you will not be able to represent the characteristics of those units in the sanitation value chains. Then, starting from the techniques, normally we have the grab and composite sample. We need to realize that how degree of variability of those units it is. And then we can select that whether just a grab sample it is possible to represent the characteristics or not. If we cannot do that, then we may need to use the composite sample. Of course, it takes more times, but it can represent better. Then this guided to the device that we use in different kind of techniques. That an example of use the simple beakers connect to the stainless steels, or use automatic samples. That also possible, but the cost would be different as well. We may need to carefully consider that how we can select the location of the samples so that the sampling technique would be different, and then we can select the different kind of a device to collect the content inside the septic tank. And then in the transportation system, like the truck, so how can we get that? It's not that easy at all. We cannot just get from the valve, or if we like to get the different layers of the sample inside the tank, so that the tube would be necessary treatment system like the conventional wastewater treatment system. So that we need to prepare carefully that whether we just like to use a grab sample or the technique to collect the sample to represent the inference of the treatment units, so that we can prepare. And then within the unit itself, we also need to think carefully that how we can select the sampling schemes that we can represent the treatment performance from the top to the bottom of the treatment units. And also that after treatment, the end use of the treated products like the dry sludge, how can we ensure that our dry sludge can comply with the standard? Of course, the surface to the bottoms, characteristics of the sludge would be different. But to represent that, we need to have an appropriate plan to collect the sample appropriately that we can explain in the chapters details, that from the beakers to the buckets and also to the tubes, and together with that, the vacuum tanks that connect to the tubes, and then we can select to the depth of the sampling units we would like to collect the sample from. And also we can even use the very advanced equipments like the laser techniques equipped with these kind of tripods. And then we can measure the contents inside the tank without any disturbing the content of the units. And then we can connect to the mobile phones, and then we can report right away the content inside the tank. And then with that schemes, we also need to be aware that inside the tank, they would have different kind of contents, only the solid, or with the liquids, or very dry solid as well. So with this kind of contents, we need to draw different schemes of plan to ensure that your sludge samples can represent the content, can represent the characteristics inside the content. And with that, after collection, we also need to manage the sample appropriately depending on the parameters you would like to analyze for, whether you like to get the blended or unblended samples, and then you can decide for each parameters. And so we need to provide enough PPE or personal protection equipment, not just only the mask like this, but also perhaps inside the treatment units, we may need to use a very advanced mask that would have different kind of techniques. And of course, with that, I'd like to thank for your kind attention. Thank you very much.
Hello, my name is Mariska Ronteltap. I work for the Delftland Water Authority, and I'm one of the co-editors of this book. I'd like to take you through Chapter 4, Experimental Methods, and highlight a little bit why we think this is a very important aspect of working in the research field in fecal sludge. Now, why would we think this is such an important element? First of all, we really want to take the whole research in fecal sludge management to the next level and get closer to how far we are with wastewater treatment technology research. This will allow us all to get more efficient and more effective treatment technologies to be implemented. Not only for the academics, this is important, but definitely also for the practitioners having to make investments to protect environmental and public health. So having proper experimental design in place, getting reliable results for this, will allow us to get reliable full-scale treatment technologies that will be ready for the future. Now, let me give you a short example. Let's say you're the head engineer of a mid-sized city, and 80% of your city relies on on-site sanitation. And you have to make a decision how to get treatment for a big part of this fecal sludge that is getting available from your on-site sanitation system. Now you have a nice salesperson coming up to you and saying, what you need is solar drying beds. They work fantastic, they are cheap, they're reliable. What you need to ask them then, show me, next to the price of course, the test results. I would like to see, do they really perform better than maybe other regular or cheaper drying beds? Show me how they work under different humidity conditions. What are the sun hours that I need? Is there a different temperature range? Do they perform well in all sorts of loading rates? You need to make sure that you are able to interpret the test results and make sure that the test results are reliable. Only then can you make a proper informed decision. So when carrying out research in fecal sludge management, you need to have a proper experimental design in order to make sure that your results are reliable, reproducible, and available for further interpretation. That's also very important because you always gain metadata that might be very relevant for other types of research. When you're designing your work, what is very important is to think, what is the scale of my experiments? How big should I think? Should I have a smaller scale with a little bit amount of fecal sludge? Am I already ready for the next stage? So if you're testing out a first hypothesis or want to check a particular element of a larger setup, then a lab scale
setup is very easy and very reliable for you to work with. An example could be, what is the necessary exposure time to UV to inactivate my pathogens in a certain setting? Then you can easily take that to the lab while you have very strictly set conditions that you can record and report on well. Now, once you're quite convinced that a certain technology might actually work, then you're ready to take it outside and start building a pilot system. A pilot system has a range of somewhere between 50 to 2,000 liters of fecal sludge that you're working with. One of the big questions you need to ask yourself, do you have enough fecal sludge available to carry out the test that you want to do? Important there is to have a system that is very flexible with plenty of access and plenty of leak-proof sampling points so that you can really test all the flow through your system and make sure that you have plenty of samples that you can work with. Now, once you have that in order and you're very happy with the outcomes, then you're ready for a full scale, which is somewhere between 1 to 800 cubic meters. And there you can really test in full-scale conditions and work with the real setting and see if maybe a different mixer can help you, or a different streaming direction, or shorten or longer the residence time that can all help you in a full-scale experiment. The chapter has a lot of case studies. It goes from choosing a different type of conditioner to scaling up the dosing. In the section on recovering fecal sludge for fuel, there are a number of case studies on the drying kinetics, on working with existing technologies, but improving certain parts of this. All the case studies take you very nicely through the experimental design. So which research questions do you need to ask yourself? Which parameters can be of influence or need to be changed? Which interferences can I expect? And so you have a very nice idea about how you could set up experimental work yourself and copy the analogy. Now, concluding, when you're doing experimental work, it's very important to first do your reading homework, see what has already been done, which parameter can play a role. Then you write your research plan. How many samples do I need to take? What are the conditions that I want to work in? Think of what can go wrong, because there can be a big list. And what is important is to think which factors can interfere. Where can I expect leakages? Where can I expect problems? And try to mitigate that already when you're safely behind your desk and not up to your ankles in fecal sludge in the lab. Well, that's much easier. There's plenty of tools in this book that you can use for your experimental design. That's the whole idea of this book. They have all the standard operating procedures, to have ideas about sampling, about storing your samples, about doing an analysis for your quality and your quantity of fecal sludge. So use all these elements from the book, and then you're really safely set to go. If you think that it will be difficult to work with real fecal sludge, or that the variability is too high, use the section on the simulants or the artificial fecal sludge recipes that can really help you to get a big batch of similar fecal sludge that helps you to get reliable results. And of course, the last part, very important, share your findings. Share with all your fellow researchers, your fellow practitioners, so you can together learn from the results and take the whole field to the next level. Good luck, and keep sharing your findings so we can really make a big improvement in fecal sludge management. Thank you very much.
I would like to introduce you to Chapter 5 by giving you a brief conceptual overview of the contents of the chapter. This is Lake Malawi. If I asked you to estimate how many fish there are in the lake, how would you go about it? I like to use this analogy for estimating quantities and qualities of fecal sludge because it represents a similar problem. Fecal sludge accumulates and is stored underground where we cannot see it. There are typically not standards for construction of containments or records of emptying frequency. But just as scientists have developed methodologies to estimate the number and types of fish, we can also develop methodologies to make reasonable estimates of quantities and qualities of fecal sludge that accumulate with time and containments. We need to be able to make projections in order to plan for and design solutions for integrated fecal sludge management, such as designing treatment facilities or emptying programs or planning future infrastructure and management strategies. Another difficulty in making projections is that fecal sludge is highly variable. The schematic on top here depicts a centralized wastewater treatment system where variable waste streams from individual households are relatively homogenized in the sewer during transport to treatment. The schematic at the bottom represents a non-sewered scenario where, in addition to the conditions being more diverse, the complexity of what is accumulating at the level of individual containment is collected and delivered batch-wise to treatment. The result is that fecal sludge that is delivered to treatment has a much greater variability than wastewater. One problem with making predictions is that qualities of fecal sludge typically do not follow a normal distribution, and so average and standard deviations alone do not provide adequate representative summary statistics. This figure from Chapter 1 on the left compares influent at the Lubigi treatment plant of wastewater and fecal sludge, and the figure on the right compares values reported in the literature for wastewater in red and fecal sludge as all the other colored dots. You can see the distribution of reported characteristics is much different for wastewater and fecal sludge. The problem with assuming a normal distribution and using averages and standard deviations is, for example, with an average value of 10 and a standard deviation of 25, about a third of randomly sampled values would be predicted to have negative values. And this is clearly not meaningful for concentrations of constituents in fecal sludge, such as total solids, volatile solids, or COD. There are many other examples given throughout the book about the variability and distribution of fecal sludge. Here's another example from Chapter 2. So we have these diverse characteristics. How can we use them to make reasonable projections? If we just make citywide averages, we know now that it will not be meaningful. So can we use statistics to find categories of data that predict or separate out different ranges of characteristics and accumulation rates in order to average out this complexity and make reasonable projections? For example, what if fecal sludge from households in a city always had a higher total solids, or if septic tanks always had a lower total solids? That's why we're looking at categories of demographic, environmental, and technical, or DET, forms of data. Demographic information such as income level is not a cause of why characteristics might be different, but there could be a correlation due to things like quality of construction or different flows of wastewater going into containment. This example from Chapter 5 shows total solids concentrations for containment type and income level in Kampala, where statistically significant different based on these notches around the median. We can then use the total number of pit latrines and septic tanks in a whole community or city, and/or the number of people at each of the income levels to make projections. The SPA part of SPA-DET refers to spatially analyzable, meaning that these types of DET data can be mapped and used to make projections about characteristics and quantities of fecal sludge that accumulate, for example, in different neighborhoods of a city. To account for the non-normal distribution of data, we use the confidence interval around the median, not the mean, in order to separate categories of data to use when making weighted averages, for example, high and low income level, or septic tank and pit latrine. We can then use these values to make a weighted average for areas that we are planning for, taking into account the different categories of data. There are further example calculations of loadings in Chapter 5, and although there is still uncertainty in projections calculated in this fashion, they are way more accurate than just taking an average of all reported values. The resolution of planning projections only needs to be as precise as the decision-making process requires. Citywide inclusive sanitation planning does not require the same level of precision as process control or optimization of treatment plants. In the book chapter are also discussions about exploring your data to find additional statistical relationships that could reduce costs of data collection or laboratory analysis, and looking forward to possibilities for remote sensing for data collection and more complex modeling. I hope that you find it useful, and I'm looking forward to hearing your feedback.
Hi, my name is Damir Brjanovic, and I will say a few words about Chapter 6 of our book, Methods for Fecal Sludge Analysis. This chapter primarily addresses approaches to modeling of on-site fecal and septic sludge containment and treatment technologies such as portable toilet, a pit latrine, and a septic tank by making maximum use of the extensive knowledge gained during more than a century of research on wastewater treatment and more than 3 decades of experience of using biological wastewater and sludge treatment modeling. This analogy is possible and logical because of the fact that in both cases, urine and feces are the main raw materials that enter into the sanitation system, be it sewered or on-site, and that the combination of physical, chemical, and biological processes is an essential component in the treatment in both cases. As the two sectors are presently rather polarized, such an extension enables further integration of sewered and on-site sanitation technologies at the system level, which is an essential step towards a citywide inclusive sanitation approach. Therefore, this chapter focuses on the development of approaches on how to model the selection of the most common sanitation technologies for fecal sludge containment and on-site treatment, recognizing that the fact that this area of interest has the most complexity and the least understanding of all the components of the urban sanitation chain. The main objectives of on-site sanitation modeling are multiple and can be summarized as to provide a tool to describe the accumulation of solids in on-site containment and treatment systems, and to assess potential strategies to minimize the volumes of sludge. Describe pathogen inactivation mechanisms and evaluate different approaches to enhance and maximize the inactivation of pathogens. Improve the prediction of the characteristics of the sludge contained, accumulated, and emptied as a tool to contribute to improving the decision-making process in the sanitation chain. And finally, to evaluate the potential recovery of resources by maximizing biogas production and enhancing nutrient recovery. Needless to say, this is just the tip of the iceberg concerning the modeling of fecal sludge management, whereas on the wastewater side, the modeling of urban drainage and sewerage and urban flood modeling have advanced to the stage that can be combined with the wastewater treatment plant modeling and modeling of receiving waters into an integrated urban sanitation model. Such an integrated model can be further extended towards a true citywide inclusive sanitation model by the inclusion of the Q&Q model presented in Chapter 5 and combination of fecal, septic sludge containment and treatment model as proposed in this chapter. Furthermore, the on-site part of the model can be extended by collection and transport models and models for on-site centralized treatment technologies. These models can be further integrated into a single holistic model at the city level. It is expected that such an integrated model will become available in the coming decades. We hope you will enjoy reading this chapter, and we are looking to your feedback. Thank you.
And last but not least, we have Chapter 8, Laboratory Procedures and Methods for Characterization of Fecal Sludge. This is the most comprehensive chapter of the book, and we have a summary of all the different methods and analysis that we have been discussing earlier on. The methods presented in this chapter are the first step towards the development of standard methods for analysis of fecal sludge. Additional method development, however, is required by laboratories around the world. For the future, as more laboratories develop new methods and adopt existing methods for the analysis of fecal sludge, a collaborative testing may take place for the verification process of these methods. In this chapter is presented a general overview of the factors to consider when conducting the laboratory analysis. In section 8.2 is provided an overview of the health and safety occupational measures for risk prevention. In section 8.3 summarized quality assurance measures, and in section 8.4 are provided overview of the included methods and guidelines of how to select methods linked to chapter 2. In section 8.5 is provided information about packaging and shipping of fecal sludge samples. And in section 8.6 are included methods for chemical and physicochemical characteristics. In 8.7 are included methods for physical and mechanical characteristics, and 8.8 contains methods for biological characteristics. As I mentioned to you, there is a number of considerations that are focused on quality control and quality assurance. And this is just one of the examples that we have included in the book. And this figure actually represents what we often see in the fecal sludge laboratories. For us, it's quite crucial to understand where we stand with the analysis and how important are the quality control and quality assurance measures. With this, I'm just going to close the video sessions for today because we are moving to a live discussion. For those of you who have not downloaded the open access publication, it's available on the IAA Publishing website. This is the link provided. The electronic version is open access. You can download it from there, or you can purchase the hard copy of the book again through the publisher. And for those of you who would like to stand a chance to win one of the copies of the book, we donated 3 of the copies for the Mastermind Challenge. So don't forget to participate in the Mastermind Challenge, and you may just win one of the 3 available copies of the book. Thank you.
All right. Thank you very much for listening. That was an overview from each one of us of what to expect in the book. And now we can proceed with the live discussions and the questions. We would encourage each one of you to pose your questions. You can pose it on the chat, or we enabled you actually for all of you to raise your hands, and then you can pose your question live during the discussion. We have about 35 minutes, but we can continue even a little bit longer if you would like to. And just before we go to that, just to check how much you have been listening to the presentation, we have 2 polls that we would like to pose to you. Okay, so the first one is, how many chapters are there in the book? Okay. Let's see. Okay. And the second question is a trick question, but if you guess it correctly, it may give you the chance of winning one of the copies of the book here. So it's very interesting to see how it's progressing. We have 42%, 46 voted. Okay. Maybe a few more votes, and then we'll close it off. Okay, 50% voted. All right. So it's great to see that the most of you have been listening correctly. We have 8 chapters of the book, and that's 92% of the replies. Some of you think that there are 10. Well, maybe in the future editions of the book, we can include 2 more chapters. But for now, we have 8. And then the next question was, how many laboratory-based methods are included in chapter 8? And quite a few have been close to the correct answer. For now, we have 49 methods, which is also quite a tricky question. And then we'll get in touch to see who replied correctly to this answer. So now we would like to move to the live discussion, and we would encourage some of you to pose your questions.
If people want to see what 49 methods there are, there's a table on page 250.
Thank you, Linda. Who would like to start first? You can raise your hand. Yes, thank you, Mariska. It's available digitally. Are there no questions?
Yeah, you can download it at the IWA website, and we also all have it on our individual web pages. Should we put the link in the chat?
Yeah, we can put the link in the chat. In the meanwhile, we have our first hand raised up by Isha.
Yes, thank you, Constantina, and glad to see some of the familiar faces. Hello, Professor Thamarat. Yeah, so I had the chance to work with him in AIT, and I have met most of you, but yeah, and yeah, thank you all the presenters for this wonderful presentation. My question would be to Linda. You mentioned about this SPA debt kind of analysis in the book that was demographic, environmental, and I forgot the T, but yeah. So in that case, yeah, in that case, like we also did some similar kind of analysis for identifying what kind of sanitation interventions would be required for one of our project towns. It is with CYSTA Hub South Asia that we are doing in MP. But I wanted to know that for this kind of fecal sludge analysis that you mentioned, this process, is it that we have to do manually for now, or there is also some kind of a tool, or there is some application where we can use this process? So that would be it for Linda. Thanks.
Yeah, unfortunately, we don't have a tool yet. We're not yet there, but and we're working together with another group here at AOVOG that is trying to make it into a more automated spatial analysis where you can enter information, and then we could also use that in the future so people can share their data through this platform and also be able to see more predictions. And the model is called GAP, which is Groundwater Assessment Platform, and it's currently used to predict arsenic in groundwater. But we're going to try to see if we can use the same hypotheses of this predictive characteristics to apply for fecal sludge. So stay posted.
Yes, thank you, Linda.
Thank you, Linda. We have the next question is from Rohini. In seaways, how do we decide the number of fecal sludge samples to be collected and from what sources? Maybe we can pose this question to Thamarat. Yeah.
Yeah. Okay. So I think that very much depends on that. What are your objective in analysis to collect those samples? That if you would like to get from the inference to your septic tank, for example, then we need to explore that how deep of information you would like to get, the variation of the inference characteristics, or just once to get the information. So that will say to you that how many samples that you should prepare, collect from the tank. Or if you would like to think about that, the performance of that kind of septic tank system, it may not be able to get only 1 gram sample from that. Then it would not be a good representative of the septic tank, the performance. So that would be very much depend on the objective of the study of your monitoring the purposes.
Thank you, Thamarat. The next question is from Andrew. Does the book cover limits of sample temperature and time allowed for transport between sampling and analysis? We have included some, for all the methods, we have included indication of what should be the sample preparation, and then also what is the preparation time. For the temperature, we have recommended some storage conditions, again, for each one of the analyses, depending on where the sludge have been collected and the type of the analysis. So yeah, some of this information is included in each one of the methods. And then also we have in table 8.3, in chapter 8, we have a description of what is the type of analysis, the preparation time of the samples, and then the analysis time for each analysis. All right, anyone else? You can raise your hand actually and pose your question directly on the chat. We would love to hear from you.
That's a very good question in the chat there.
Yes, go for it, Linda.
We take samples from a wet pit latrine that has not been emptied for a long time. Should we mix the sludge or take samples from different heights? Usually the bottom sludge is quite thick and often cannot be desludged or emptied by a vacuum truck. Tamarat, what do you think about that?
Yeah, I think to take the sample from the wet pit latrine is quite a challenge, that especially for the long term. And well, we have to consider first is that whether there is a kind of the perforation or the leak of the liquid parts or not. If not, then it means that you accumulate the very high concentration of the solid content inside the tank, so that it would be very tough to get that, so that the tubes or the sampling device you have to select properly, and then you can get the good sample through the depths. And then you ask about the mixing requirements for the different height. As I show you in the graphics of the septic tank or the wet pit latrine and some others, we need to understand to try to think about what would be the differences between that if you have the use of the liquid for flushing into the tank, then it would have a very high liquid proportions of that. Then for me, it would be rather simple to get the sample out. But if it is dry pit latrines, then it would be quite difficult to get it out, especially that to the bottoms. And normally for such a very poor design or the construction of the pit latrine, it is very difficult to get up to the bottoms. We don't know exactly that whether it is 1 meter, 2 meters, or 3 meters. Somehow we feel that it is already reached, but it is exactly because the solid is so dry in the bottoms, but we don't know. So that could be quite a challenging step to get the bottom parts. If it is a liquid parts like the septage in the septic tank, we can use that the vacuum tank that we can design at particular depth. Then we can turn on the valve to get the sample right and at the depth of the septic tank if you would like to. That's what would my answer. Tina?
So just re-emphasize what Tamarat said earlier, that how you take the sample is also going to depend on your objective, why you're taking the sample. And also just to include in chapter 3, Tamarat's chapter on sampling, there's also lots of examples of actual physical types of sampling devices. So if you want to ask, how can you physically capture liquid versus solid, there are examples in chapter 3.
Thank you, Linda. Thank you for all the questions. We have a question from Lungi. Lungi, we would like to hear from you live, if it's okay.
Hi, that's fine, Tina. Hi, everyone. Hi. My question was just around if the book includes any simple, quick methods that can be done on site if you want an answer quickly and you don't have time to take the sample to the lab and wait for 24 hours to get an answer. Does the book include those type of analyses? And also, looking at those quick and dirty analyses, can we use some of them to infer other more complicated parameters that we'd want to find out? Thank you.
Thank you very much, Lungi, for this question. We have included some simple analysis for some of the chemical parameters that could be used in the field, and then some other simple analysis. But one of the reasons why we did not include a simplified, quick and easy types of tests is that there are other publications, for example, from the Austrian Red Cross and EAVAG. There is an example of field-based fecal sludge laboratories, and they also provided this kind of quick and easy methods. So maybe Linda, you can say a few words about this publication.
Yeah, we have a fecal sludge field laboratory that was developed for emergency and humanitarian settings where there's not laboratory capacity. And we're further now starting to work on further adapting it for in general conditions where people don't have access to laboratories. There are also some examples in chapter 5 about using statistical patterns that you see in your sampling campaigns in order to predict. So for example, if you have a strong correlation between total solids and COD concentration, and you consistently see that in your town, then you could use that and sample total solids to predict COD. But that's going to be city specific. Another thing that's covered in chapter 5 is an app, or maybe it's in chapter 4, sorry, forget the numbers now, we're working on developing an app so that we can take pictures of fecal sludge and then based on the color, predict characteristics and dewaterability. So we've now developed that for the city of Lusaka based on a couple hundred samples that we collected there, and we hope to also expand that into the future. So great question, Lungi. We don't have that available yet, but the book was just launched, and so that we hope that everybody can start working on things like that together now. And as Mariska said, also to really emphasize the sharing of our data so that we can develop more tools like that.
Thank you very much.
Thank you. I'm hoping I'm pronouncing the name correctly, Vishwakarma University. There is a question, probably Damir could reply to this question with regards to the global laboratory partnership. We would like to know if we'll be able to set up complete fecal sludge analysis lab like we do. Do we have devices, instrument mentions as well in the book? And considering the SOPs included there, is it going to be very helpful? It is going to be very helpful for updating the existing center with separate branch for fecal sludge analysis.
Yeah, I think many of the laboratories which are already partners in the partnership of laboratories for fecal sludge analysis didn't start as fecal sludge labs. So I think the fecal sludge capacity was built on the existing capacity in the labs which are normally used for drinking water, soil, and wastewater analysis. And then a number of instruments and expertise have been built up with the samples from the non-sewer sanitation. So yes, my answer is yes. We are encouraging the general labs to expand with the analysis for fecal sludge, and it's not a big step. It's only if you look, depending what you have already. So you need to see what is your present capacity and how easy or how difficult it is to reach that level that you can call your laboratory a fecal sludge lab. Now for the guidance, the best is to download the brochure on our partnership, and on the first page of the brochure you will see the overview of all kind of analysis and instrumentation that these 11 laboratories have. And you will see that some labs are really equipped very, very well, and some are equipped less, but still they qualify for that category of being a fecal sludge. And there you can get a good impression what kind of analysis you need to have in your lab to be in that let's say league of partnerships. And then you can look for what are you missing and find out, are there any alternatives ways? Because in our book, we not only present one way of analyzing things, wherever possible, we also describe several different apparatus or setups that can be used for analysis. So if you don't have that particular one, you might have alternative one, which will give you still good results. So it's all possible. It needs some expertise, and the best way to look for advice is from the partnership itself, because we are there, all of us present in this board are members of the partnership, and there are more laboratories. And I know you are a member of a Global Sanitation Graduate School, and you are also entitled as a member also to get access to this knowledge and information. So please contact us and we will work with you on more details. And not only you, everyone who wants to join us and everyone who needs assistance or help, we are open to serve you.
Thank you so much, Damir. Yeah, I think it's also a good time to mention, and it also reflects on Lungi's question before. We said it many times, but it's just a good reminder that this was tremendous effort to start the foundation of a standardization approach. And we may not have included all the methods that we would have liked to. We would work towards including more simplified methods, even more comprehensive methods, but that's the first step, and we would like to set up the foundation, something like that would be a lot more as a unified approach of how to do sampling, how to do the analysis, how to set up the laboratories, and then we are hoping to work on this collaboratively through the global laboratory partnership for fecal sludge analysis.
Yeah, that's a good point, and I think it's relevant to Jan's comment there.
Yes, so let's move to Jan's comment, which is very interesting. So Jan is asking, how long did it take us to put the book together and yeah, into the entire writing process?
Tina, did we start all talking about it 8 years ago? About?
If not more. Yes.
I was wondering if there was no pandemic the last year, if we really would have finished it.
Probably no, because we would have still traveled the world and we would kept talking and adding more content to the book. Yes, so the conversation started, I'm pretty sure even more than 8 years ago. And we started realizing that us as partners in the field, we were generating data from the field. We were also working with different partners generating data. And the major challenge was that since we don't have the standard methods for fecal sludge analysis and sampling and collection and storage, we would all use our own standard procedures based on different standard methods from the wastewater field, from soil science. The problem with that came when we were trying together to put presentations or to compare data published by other authors in the other side of the world, who have used different standard operating procedures, who have modified different standard methods in the way that fits into their own capacity. And we started asking the question, how is this data comparable? Because we've been using completely different methods, and then the sludge characteristics are so heterogeneous. How can we even unify this into a more standardized approach? And it appeared as a big challenge. That's why it took us a while before we even initiated this project. But we thought that once we set up the foundation towards this, it would be a really valuable information. I don't know if anyone else would like to add.
No, I agree 100% with what Tina said. I mean, a fecal sludge is not only so variable, that's when you talked about the importance of precision and accuracy, but if we're not all using the same methods, our results aren't comparable. I think also the book evolved from just laboratory methods to also what's the background information you need to apply the methods, and then also some ways that you can use your results, for example, in modeling.
It is correct. Yes. Okay, next question. That's from Vishwakarma University in Pune, India. We are including the book as reference book in syllabus for MSc program, wastewater and sanitation management. Oh, that's just a comment.
Yes, thank you very much.
Including. Thank you very much.
We'll also be looking forward to getting your feedback on the methods in the book.
Okay. Are there any additional questions?
I have maybe, while we are waiting for the questions, I have maybe a good news for audience and for the Sanitation Society. And that is that, yes, it took us quite some time to get this book ready, and we are all happy with the result. I must say we are all so proud and so happy. I just got the book last week in my hands, so the feeling having it in the hands, it's much better than having it online. So, you know, so yes, great. But the good news are that we are thinking about translating the book in several languages, like it was for our fecal sludge management book. We would like to translate this book into French, Chinese, Hindi, Arabic, Spanish, Russian, and any language that we have interest in. So that's coming in. I think toward the end of this year there will be some developments, probably next year. And what we would really love to do is to turn this book into online mode, so that we have a set of filmed, recorded methods, and each chapter with the examples like Tamarat showed. I mean, everybody immediately liked it so much more when they saw wetlands and plants and septic tanks and toilets. We love that. So that's what we want to do. We want to turn the theory into practice as well, and to show this practice which is already there. And that's a huge job. I promise you, we are going to stick together to be open for new authors and new contributors from the laboratories and feedbacks, as Linda said. And so that is another addition that we hope to have in a coming year or two, so that you have entire set and the book and the set of materials that you can use for practitioners, for students, for laboratory staff, for PhD students, postdocs, master students, undergraduate students. Pretty much everyone needs that. And we are going to do it. How? I don't know, but we did so far many things that we didn't know, and we made it at the end.
We can perhaps call for volunteers on the translation process from any of the members to this call.
Yes, we just started
like
that
to
idea.
Participate.
Yes, so we are open for people who know the terminology, who know the field, but also are good in languages, so that it can be turned into different languages. We have a first book in a Tamil, we have it in Marathi, we have it in Croatian, we have it, wherever there is a little enthusiasm, we are going to support it. And also the publisher is very keen of supporting us.
We're also going to need many volunteers to help us with testing the methods. So, I mean, we've talked about it, that we want standard methods. These aren't standard methods yet. Now that we put them out there, we need people to be testing them in their laboratories. And Damir spoke a bit about that earlier.
Yes, this is correct. And this leads us to the next question from Jan. Again, how many regions have tested the methods, and were there any regional variables included? I think that's a very tricky question.
Mm-hmm.
Tamarat?
Well, I think at least to our point of views, we exchange between Asia and South Africa and the Netherlands, the Swiss experience in the region. EAVAC also have been working a lot in the Southeast Asia through our partner institution in Vietnam, in Indonesia. AAT also works a lot in that. And then I think with the Chris Buckley initiative, I think we have exchanged several researchers together, and then we can try to adopt and adapt each our own techniques to samples, to analyze, to get the right data. I think that would be one way that we try to help modify the technologies or the analytical parts that to conform with each other. Otherwise, it will be not transferable information to each other. So that I think at least within our groups, we have exchanged and also transfer the information together and try to adopt ourselves into that conformation of the techniques, I think.
Thank you. Linda, would you like to add anything to that?
No, just also what Tamarat said. I think now the methods, we have experience from all over the world now, more in some regions than others. And how are there regional variables? I think that's also something that Tamarat discussed in the sampling chapter about, how do we account for this variability? How do we sample from different types of sanitation systems? So hopefully we don't see differences in the effectiveness of the methods in different regions, but that we can adapt with the tools that we provided, the methods to all the different situations.
Thank you.
Yeah, and one of the other next steps is now we have this database, which is still, let's say, in a raw database, and we would like to work further on it. So to work out the existing data into some more meaningful database that can be more interactive and that a regular user can relatively easily mine data from there. So for researchers, invaluable, or that labs can compare their data with the regions which are similar to theirs or countries which are similar to theirs. But also that is very important to build up this database with the new data. So we would like to invite everyone who is working with the labs and analysis to feed us with this data. Even we can put it for you in the database with the proper referencing and build up that bank of data. And these can be shared or are shared already, but can be further used for other purposes. When we have more data, we have bigger samples, we can do much better statistics on it. We can do modeling using these large data sets. We can do artificial intelligence by extrapolating this data, what Tamara said, for cases that you cannot sample. Maybe there are similar data already, so you don't have to sample. And maybe only with few samples, you can extrapolate to much more knowledge. So what we are doing, we are building foundations for a much bigger thing. And we need everybody to contribute to that to make it possible for the benefit of all users.
Thank you, Damir. I also wanted to add that actually we tried to reflect on the regional variations by trying to provide methods or the preparation for the different methods is different depending on the total solids content of samples. And then we know that in different regions, we may have more liquid sludges or more dry sludges. It obviously depends on the type of on-site containments, but we try to provide more simplistic way of how we can classify the sludge and how we can break down the heterogeneity of the fecal sludge based on including in regional variations, and try from there to extract and work onto 1 or 2 or 3 types of standardized approaches for analysis, depending on the type of sludge. So as we mentioned already, It's not perfect yet, but we are working towards the perfection slowly and with your help as well. So your comments and your feedback is really, really valuable to us. Mariska, would you like to add on?
Well, I added already some things in the site. So yeah, I think many things we've discussed so far. And but yeah, I think we're all very excited to have this fundament laid out for both doing the experimental work, as doing the sampling, as doing the preparation and doing the analysis, to really have a joint foundation for all of the people working in this field globally. And yeah, I really feel that we can do this leapfrogging. Yeah? We've been doing research in the field of wastewater treatment for 50, 60 years, and now we need to catch up. So I think we made a really nice foundation in that. And I'm very excited to see again the FSM, the next one, to see which results came out.
Thank you. And I think with this, maybe we should wrap up the session. I would firstly like to thank you all for joining us. And I would like to thank you all colleagues for working together after a long pandemic. It feels like a nice reunion for us. So we would also like to thank, or I would like to thank on behalf of all the editors, to all the contributors and reviewers to this book. It was a tremendous international effort. Thank you very much, colleagues, for all your time and work. Yes, you can see on the back cover that Linda shows you how many contributors we had. And there was a lot more hard work behind the scene that is not even captured here. And the last thing, I would let all of you to say your final note. The last thing I wanted to remind you is that if you would like to win, there are 3 copies of the book that have been donated by us to the Mastermind Challenge of the conference. So if you would like to get your copy, please do your Mastermind Challenge through the days of the conference, so you can earn a hard copy of the book.
And sorry, just to add, if you're doing the Mastermind quiz, you can't pause, because I actually tried to do that and then I got 0. So don't try to pause.
I also tried to do that and I had 0 points. You're not alone.
It's a bit embarrassing.
Anyone else?
Okay, thank you.
Thank you very much.
Thank you. Have a nice conference.
Thank you. Enjoy the conference.
So we need a champagne.
Oh, yes.
To celebrate the book.
I have one.
Yes, we couldn't celebrate yet. Hopefully sometime soon. Thank you, everyone. It was wonderful to see you.
Bye.
Bye.